Good evening, students. Welcome to Career Foundations Class 2. So here we are continuing with the last class. We had covered SI system in the last class, and we had understood of the SI basic quantities and supplementary quantities, their respective units and their symbols. Now today we are going to understand rules for writing SI unit in a symbolic form. ಯಾವ ರೀತಿ ರೂಲ್ಸ್ ಪ್ರಕಾರ ಅದನ್ನು ಸಿಂಬಲ್ಸ್ ಬರೀಬೇಕು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಮೀಟರ್ ಈಸ್ ದೇರ್, ಸ್ಮಾಲ್ ಎಮ್, and you cannot write as a capital letter. Small letters are used for the symbols. Okay, ಎಲ್ಲದಕ್ಕೂ ಅಲ್ಲ. Okay, so first one is we should write small letters for the symbols. Now second one is full stop, comma, otherwise punctuation marks are not to be written after symbols of unit. For example, ನೋಡ್ರಿ, ಮೀಟರ್ ಈಗ ನಾವೇನು ಎಮ್ ಡಾಟ್ ಅಂತ ಹಿಂಗೆ ಬರೀಲಿಕ್ಕೆ ಬರೋದಲ್ಲ. We cannot write like this. This one we cannot write because that is the rule to write the symbols of SI unit. Okay, the initial letter of the symbol is capital only if when unit is named after a scientist. For example, electric current is named after the scientist who formed it, who understood and invented it, and that's why the symbol is written capital A. Same like that for temperature, Kelvin, capital K is written. Okay, so this one we know. Now the full name of the unit with a small letter, even if it is named after a scientist. For example, say, okay, so for current, capital A we have written, but while writing full ampere anta avagenanta bariತೀವಿ, small a we will start. So we will work out with a small a. Like this we will write ampere. So like that we will write. So this small a should be written, but when symbol has to be written, symbol should be written in the capital form. So that is important that we have. Okay, so this is one thing that we understand. Now next we will go. Symbol do not take plural form. That means, for example, Kelvin is there. Okay, Kelvins we cannot write. K's, K barada apostrophe S we cannot write. And sixth one is there should not be space between a prefix and symbol. Like kilometer anta ಬರೆಯುವಾಗ ಕಂಟಿನ್ಯೂ ಬರೀಬೇಕು, KM ಅಂತೇಳಿ, otherwise it will be meaningless. So these are the rules that we understood. Now what is multiples and submultiples? Multiples and submultiples is 10 raised to plus power. 10 raised to plus power ige multiple ಅಂತಂತೀವಿ. 10 raised to minus powers ige submultiple. For example, 10 raised to plus 3 ಅದು multiple. So 10 raised to minus 3 ಅಂದರೆ sub multiples. Now the list what we have seen, what we are seeing right now on the screen, so there are so many over here, you can see. Okay, so 10 raised to minus 18 to 10 raised to plus 18 it is given. Okay, so in the 10 raised to minus 18, first one if I take, it is prefix is called atto, and we see that its symbol is small a, and then example attometer. Other 10 raised to plus 18, you can see plus 18. So we see that excite is given capital A, capital E we symbolize and give an example. Like that there are so many like this over here. Power form, and then prefix is given, symbol is given, example is given. Please note them. ಇದನ್ನು ನೆನಪಿಟ್ಕೊಳ್ಬೇಕು. ಏನು ಕೇಳ್ತಾರೆ, 10 raised to 3 means A, ಮಿಲಿ, B, ಮೆಗಾ, C, D ಹಿಂಗೆ ಕೊಟ್ಟಾಗ 10 raised to 3 ಏನಂತ ಹೇಳ್ತಾರೆ, 10 raised to 3 ಕಿಲೋ ಅಂತ ಹೇಳ್ತಾರೆ. ಸೊ ಇಟ್ ಈಸ್ ಹಿಯರ್ ಯು ಸಿ 10 raised to 3 kilo is there, and K is a symbol for that. So like that you will have to study all that list over there. For what power form, what prefix is there, what symbol is given, what example you can give. So while coming on the direct class, I will give so many examples there. You can read all of them. Now let us go for the next slide. Now we are coming to a very important part of this chapter, that is measurements. Measurement, anything measurement means what? ಒಂದು ಮೆಜರ್ಮೆಂಟ್ ಮಾಡಬೇಕಪ್ಪ, ಒಂದು ಕ್ಲಾತ್ ಮೆಜರ್ಮೆಂಟ್ ಮಾಡಬೇಕಂದ್ರೆ ಇಟ್ ಈಸ್ ಕಂಪ್ಯಾರಿಷನ್ ಟು ಎ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಕ್ವಾಂಟಿಟಿ ಆರ್ ಯೂನಿಟ್. For example, one full cloth length is given. How much it is, how you are going to measure it with the scale of 1 meter scale. You will use it. So comparison of the whole quantity with the standard quantity is called measurement. Now let us take what is measuring instruments. There are so many measuring instruments. Example, you can see our own scale, ordinary scale, what we are using is also a measuring instrument. Wall clock is a measuring instrument for the time. But for a diploma and even for the practicals, two measuring instrument we have understood. That is what? One is vernier calipers, another is a screw gauge. Okay, let's go further then. Understand. The error is there, types of error is there. One by one we will understand these things. Okay, now I told you what is measurement. Measuring instruments, two measuring instruments are there. Error is actually some difference between the true value and observed value. For example, what is true value? Say for a length I measured as its actual measurement is 10 meter, but I measured it as what? 10.1. So 10.1 minus 10, that is 0.1, is the error. So types of errors are there. You go through it. Systematic error means error because of instrument. Instrument in the manufacturing only it is wrongly manufactured, so some alignment is missing. That's why whenever you use that instrument for any measurement, that standard error happens. That standard error is called systematic error. Random error means it keeps changing. That is because of human being error. See, sometimes when we take vernier calipers, want to measure some length, it will come 10.1, next time the same thing 10.2. So this is called a random error. Absolute error is there, relative error is there, respective definition is there. Please understand it. And down there is a correction. It is called plus or minus zero error. When we understand zero error, we will tell you what is zero correction. Okay, let us go for particularly now instruments called. First instrument is vernier calipers. Right side you will see. Okay, so here on the right side you can see here. Okay, the what you say, the parts of the vernier calipers. First one is lower jaws. Lower jaws means this ones. Say, so this one are lower jaws. Upper jaws means this one, these two. Okay, and then depth bar is there. Depth bar means this one. And then main scale means this is the main scale. Vernier scale means this scale which slides on the main scale. Okay, so after finding out this one, there are few things that we will understand. It comes one by one. Let us understand all of them at a time. Now say, lowest count of the instrument means what? Now we are not particularly telling vernier caliper, screw gauge here. Common word, least count of instrument. That instrument can be wall clock, can be vernier calipers, screw gauge, or they can be what? Even or simple scale what you are using. But that is least count of the instrument. Simple. What is the least count means? The least measurement it can do. For example, wall clock is there. It can do the least measurement as what? Only 1 second is the least measurement. That is its least count. Now for our common scale, which is a feet scale that we have in the centimeter, this one level, so we see that 1 mm or 0.1 centimeter is the least count of that scale. Just like that, least count of instrument means it is the smallest measurement that an instrument can do. Okay, let us now take, so first one is over. Let us now take now particularly principle of vernier calipers. What is the principle? You have to remember by hand that the vernier is the secondary scale sliding on the main scale. This vernier scale is the secondary scale we call, and main scale we call it is a primary scale. Secondary scale sliding on the primary or main scale. That is called what? The principle. Or you should remember this, very important. N main scale division is converted to N plus 1 equal divisions on vernier scale. Okay, remember that by heart it because it's very important. LC of vernier calipers. Now see, on top you are saying LC means least count of instrument in general, but here in particular LC of vernier calipers means same definition. The smallest measurement that can be done by the vernier calipers is called LC of vernier calipers. You can give the formulas connected to two formulas are there. First formula, LC is equal to 1 main scale division minus 1 vernier scale division. That is first formula. Second formula you can use, that is the laboratory we have used this formula. LC is equal to smallest division on main scale divided by total number of divisions on vernier scale, and for measurement of any of the say diameter or volume of any of the object, we are using this formula. Total reading TR is equal to MSR plus coinciding vernier scale division into LC. Now in general they may ask you one question, where for the diploma where it is useful. Now its uses is very vast. It is used in the industries a lot, vernier calipers, but they will ask you in the border of the diploma syllabus, and we know that in diploma in your lab you have done 3 experiments over here: volume of the solid cylinder, hollow cylinder and sphere. Respective formulas are given. By heart them because they are useful for our for problems that we will solve in the future. Now let's go for the next instrument. Now next instrument is our screw gauge. Now in our screw gauge there are a few things that we have to understand once at a time. You can just have an idea of it. This is the instrument that we have. In this instrument you see the parts is directly given there. Anvil is there, spindle is there, sleeve, and main scale they say this main scale is nothing but pitch scale, and rotating scale they say that is nothing but head scale, thimble, ratchet and frame. Now this is useful. Now what is the principle of this? Let's understand about the differences between two later on, but let us understand this instrument in the first place. What is the principle of this? The principle of this is it works on principle of screw and nut. Screw means actually the screw is nothing but this pitch scale, and nut will be head scale. As the screw goes inside the, or you can just try to move inside the nut or unscrew it, just like that this instrument also, the pitch scale and the head scale operates just like screw and nut. Now pitch of the screw, okay, now pitch of the screw is given by for one complete rotation. If you rotate this for one rotation, how much distance is moved on this, okay, that is called pitch of the screw. So distance uncovered on pitch scale and divided by total number of divisions on that. There's a division line here, please draw it. Okay, I missed it. Please draw it. Okay, pitch means what? Pitch is the distance between any two consecutive threads is called pitch. That is also there. So you see now threads are there on the screws. So distance between one thread and second thread is called what? A pitch. And the formulas given, LC formulas, you please write that formula. Okay, right, there's some overlapping, we can understand it later. Okay, now let us come and uses we have seen. Okay, uses there, see thickness of the glass plate, metal plate is there, volume of the sphere, volume of the wire, so many places, and their formulas are given in the previous slide. You can do it. Now I want to tell you what is the real difference between vernier calipers and screw gauge. Question number 1. Which instrument is more accurate? Screw gauge is more accurate. Why? Why? Because LC of screw gauge is far more less than what the vernier calipers. That means it can measure more accurately than vernier calipers. But second thing is, what vernier caliper can do is it can measure the outer diameter as well as inner diameter with the upper jaws, but in screw gauge we don't have that provision. In screw gauge we cannot measure the inner diameter, so screw gauge we cannot use for finding out the hollow cylinder volume because it cannot measure the inner diameter, but vernier calipers is used. So there are some advantages also over that. But normally, which is the accurate measurement that we would like to say for the outer diameter measurement is, it is screw gauge. And and for the very small object, which one we will use is, mainly we will use screw gauge. So these two instruments play an important role tomorrow in the industry, that this on the lathe machines or so many other machines on the mechanical branch, especially or civil branch, you will be using these instruments, or principle of this instrument, or instrument based on the principle of vernier calipers or screw gauge is used. We will solve the remember the formulas, we will solve the problem on the formula in the coming days. Okay, now last thing is about the zero error of screw gauge. Zero error, positive error and negative error and no error. See, now let us see this diagrammatically, because we will not understand that. Suppose this is head scale. Suppose this is head scale and scale 0 is here. Okay, head scale 0 and this is a 0. Now this is pitch scale. Now for the pitch scale, see 0 of this. Let me go back a little about 0. Suppose this is a pitch scale. Now 0 of this head scale, if it comes down here below the baseline, then it is positive. If the 0 of the head scale is above the baseline, it is negative. If at all 0 of the head scale is along with this, it is along with this, here 0 is there, then it is having no error. So this is what it is. Now 0 correction means what? There is a mistake over here. It is equal to plus or minus 0, not correction, it is 0 error. So 0 correction is equal to plus or minus 0 error. So students, we have learned so many things. Thank you for your patience, but we have learned so many things over here. My one explanation of this may give you around 35 to 40% of the accuracy, because it's unlike, the classroom teaching on the board is entirely different from the online or YouTube or video classes. But because the situation demands, we are doing this. If we are permitted, tomorrow itself we will start the class, and the same video class will be sent to all the outstation students also. Don't worry, we will repeat all this once the classroom permission is given to us. Okay, until then you go through this, work for the primary level, then we will repeat it, and definitely we will give you the quality out of it. Next class, in the third class, we will be probably going for the problems, or we will continue the class and then cover some more material, and then later on we can go for the problems of the respective formulas over here. God bless you.